Okay, let's start. Let's start. Part A, question number 1. Part A, question number 1. Do with me, yeah? Do with me. Question number 1. Here given P in between -1 to +1 range and Px given 4x cube minus 3x minus P and alpha given 1/3 cos inverse P, 3 alpha cos inverse P, then cos 3 alpha equal P, expand 4 cos cube alpha minus 3 cos alpha equal P, 4 cos cube alpha, 3 cos alpha minus P 0. Here because of this, you compare these two, therefore P cos alpha, we get 0. Therefore, cos alpha is a root. Therefore, alpha is a root. Alpha is a root. Alpha is a root. Then alpha mean cos inverse 1/3 cos inverse P. Therefore, 1/3 cos inverse P is a root. That is question number 1. Question number 1. Do with me. Question number 2. Here 1 over x plus a, 1 over x plus b equal 1 over c. First get quadratic equation. X plus b, x plus a times c, x plus a, x plus b, then expand x square plus a plus b, x plus ab, then here c 2x a plus b. Take all terms into one side, x square plus a plus b minus 2c, x plus ab minus c times a plus b, 0. Okay. So here roots are equal in magnitude and opposite in signs. That means alpha and minus alpha. Therefore, root sum alpha plus minus alpha, root sum equal minus b over a plus b minus 2c. Then here 0 equal minus a plus b plus c plus 2c. Then c value equal a plus b divided by 2. Then root product equal c over a, ab minus c, a plus b divided by a mean 1. No? Then ab, c mean a plus b over 2, a plus b, then simplify. Here 2 common denominator, 2ab minus a square plus b square plus 2ab. Then cancel, we get minus a square plus b square divided by 2. Quadratic relation, question number 2. So, here this paper contains part A and part B. Part A 10 questions, part B 7 questions, but not standard format. Not standard. The paper structure is okay, but the question not in standard format. But anyway, you try. Yeah. Question number 3. Here log 5 base, log 2 base, log 3 base, log 2 base 512. Here simplify log 5 base, log 2 base, log 3 base, log 2 base, 2 to the power 9 here, 9 put, log 5, log 2, log 3 base, 9 log 2 base 2, we know this is 1, then log 5, log 2, log 3, 3 square, put 2 here, then log 5, log 2, 2 log 3 base 3, again 1, then log 5, log 2 base 2, that also 1, then log 5 base 1, 0. Now equal to right hand side. That is question number 3. Do with me questions. Then question number 4. Limit question, limit x goes to 0. Sin x divided by 2 over sin x. Simplify. Limit x goes 0. Sin x over 2. Here sin x. 2 sin x over 2. Cos x over 2. Cancel this. Then substitute 0. 2 cos 0. 1 over 2. That is question number 4. Then question number 5. Y equal tan inverse x square plus 1 root minus 1 over x. Need to find dy over dx at x equals 1. At x equals 1. Then here x equals 1, then you can directly differentiate this function. Or you can substitute values. You can get substitution. But anyway, you better to differentiate at once. Then here dy divided by dx 1 over 1 plus here x square plus 1 root minus 1 over x square into x square denominator times derivative of numerator times derivative of denominator. Okay, then dy over dx at x equals 1, here 1 1, here root 2 minus 1 1 1 1 root 2 minus root 2 minus 1 or 1. Now you can simplify 1 over root 2 here. Here get common denominator root 2. 1 minus root 2. 1 minus 2 minus 2 plus root 2. Then root 2 minus 1 over 2. Root 2 minus 1 over 2. Likewise, you can get the values. That is up to question number 5. That is up to question number 5. Do with me. Okay. Now question number 6. Question number 6. Yeah, integration question. Integration question. Rational trigonometric function. Sorry, linear trigonometric function in denominator. We call this is rational trigonometric function integral. But still we haven't discussed this. But anyway, we do this. I given dx divided by 4 plus 5 sin x. 5 sin x. Here for this case we use substitution tan x over 2 equal t substitution. Then sec qua x over 2 times half dx equal dt. Do with me. Dx equal 2 dt over sec qua x over 2 dt 1 plus tan squared x over 2 then 2 dt over 1 plus t squared. Similarly sin x equal 2 tan x over 2 1 plus tan squared x over 2. Then we write here 2t over 1 plus t squared. Then write dx that 2 dt over 1 plus t squared 4 plus 5 2t over 1 plus t square. Simplify 2 common, take outside. dt multiplied by 1 plus t square both numerator and denominator. 4 1 plus t square 10t. Then 2 dt. Then divide by 2. Then 2t square plus 5t plus 2. Then here we have partial fractions. Here we have factors t, 2t, 2, 1, 1 plus plus. Then you can get partial fractions t plus 2, 2t plus 1 dt. Put minus 2, minus 1 third. Minus 2, minus 1 third. Put half, half, 2 third. Minus half plus 2 third. Okay, then you can integrate this. Minus 1 third integral dt over t plus 2 plus 2 third dt over 2t plus 1. Better put this 2 inside. Then we have denominator derivative in numerator. Minus 1 third ln t plus 2 mod c1 1 third ln 2t plus 1 mod plus c2. Then here log no. Then log difference means division. Then 1 third ln here 2t plus 1 over t plus 2 plus c arbitrary constant. Then instead of t you put tan x over 2. Then 1 third ln 2 tan x over 2 plus 1 tan x over 2 plus 1 modulus plus c. Okay, that is not suitable for part A question. That is question number 6. Then question number 7, mathematical induction question. Take fn equal 5 to the power n minus 3 to the power n positive integer. Positive integer. Let n equal 1, then f1 5 to the power 1 minus 3 to the power 1 2, then divisible by 2. Therefore true for n equal 1. Let assume that the relation is true for n equal p. Here p positive integer, p in between 1 to n. Therefore fp equal 5 to the power p minus 3p. You write here 2k, where k integer. K integer. Take here 1. When let n equal p plus 1. Okay, n equal p plus 1. If p plus 1 equal 5 to the power p plus 1, 3 to the power p plus 1, 5 times 5 to the power 3 p, 3 times 3 to the power p, then 5 to the power p put here, 2k minus plus 3p, 3 to the power p. Then 2 into 5 into k. Then 5 minus 3, 2. 3 to the power p. Then take 2 outside. 5k plus 3 to the power p. Then finally you write here 2k dash. Define k dash. That is integer. Therefore, divisible by 2. Therefore, true for n equal p plus 1. Therefore, by the principle of mathematical induction, the result is true for all positive integers of n. All positive integers of n. Okay. That is question number 7. Complete. Okay. Then question number 9. Sorry, question number 8. Question number 8. A equal tan inverse 1 over 7. Then tan A equal 1 over 7 cos 2a. Cos 2a write in terms of tan square 1 over 7, tan squared x, tan squared a, 1 plus tan squared a, 1 over 7 square, 1 over 7 square, 49 minus 1, 49 plus 1, 48 over 49, 24 over here 50, 24 over 25. Then b equal tan inverse 1/3, tan b equal 1/3, then sin 4b equal 2 sin 2b cos 2b. Then write 2b sin and cos 2b in terms of tan. 2 tan b, 1 plus tan square b, 1 minus tan square b, 1 plus tan square b. Then for tan b 1/3, 1 plus 1/3 squared, 1 minus 1/3 square, 1 plus 1/3 squared. Simplify. Here 4, 3, 9, 10. Here 8, 10. Simplify further. 4, 5, 5, 24 over 25. Therefore, finally you write sin cos 2a, sin 4b equal 24 over 25. 24 over 25. That is question number 7 and 9. 8 take karena ni. 8 lagi lang karena. Okay, complete. Question number 9. Here this trigonometry, very important part. Cos 2a equal 1 minus tan squared or 1 plus tan squared. So we use that same relation here, sin x equal 2 tan x over 2, 1 plus tan squared x over 2 in integration. Then cos 2b, sin 2b, 2 tan b, 1 plus tan square b. Cos 2b, 1 minus tan square b or 1 plus tan square b. That means we can write in terms of tan. That's the specialty. Okay, then let's move to question number 8. Okay, question number 8. Here, angle bisectors equation 4x minus 3y plus 1 equals 0 and 5x plus 6y plus 4 equals 0. Then write bisectors, angle bisectors. We have direct formula 4x minus 3y plus 1 divided by 4 square plus 3 square root. Here, coefficients 4, 3, no? Then plus or minus 5x plus 6y plus 4 over 5 square plus 6 square root. We have direct formula for angle bisector. Then you can simplify a little. Here 25, 36. 25, 36. Then here 50, 61. Then 61 root 4x minus 3y plus 1. Here 5, no? Plus or minus 5. 5x plus 6y plus 4. Here angle bisector equation. You can separate it, okay? But here we can write as a couple of equation. Here no need to separate, but anyway if you can separate, that is okay. Then I move to question number 10. Question number 10. Cos 36 minus cos 72. So these two are special angles. Special angles, but if we simplify this, it's too difficult to simplify. Okay, to find cos 36 and 72 separately. Then you better to get CD first. Cos minus cos 2 sin, sin. C plus D over 2, 108 of 254. D minus C over 2, 36 over 2, 18. This is CD. Now let's do this say. 2 sin 54 sin 18, you divide by cos 18 and multiply by cos 18. Then when you take these three together, 2 sin 30, here sin 36, sin 54, cos 18. Here 2 sin theta cos theta. 2 sin theta cos theta. Then again you multiply cos 18, cos 36 upstairs and downstairs, sin 36, cos 36, sin 54. Then again multiply by 2. Then when you take these three together, that is sin 72, sin 54, 2 cos 18, sin 36. Then 54 you can write 90 minus 36. 90 minus 36. 72 you can write 90 minus 18. Then sin 90 minus theta cos 18 cos 36 divided by 2 cos 18 cos 36. Then cancel, 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 half. That is question number 10. Question number 10. Okay. Complete them. Complete them. ඒක අහන්නේ නැහැ නේද? සෙපරේට් කරන්න කියලා නැහැ. දෙවෙනි පේපර් එක හම්බුනේ නැති කට්ටිය පොඩ්ඩක් ඉල්ල ගන්න. හම්බුණා? දෙවෙනි හම්බුණාද? දෙවෙනි පේපර් හම්බුණාද? හම්බුණා. Okay, then question number 11. Question number 11. Part A. Px square qx plus r equals 0. Roots alpha beta. Then alpha plus beta roots relation minus q divided by p. Alpha beta r divided by p. Here need to get equation with roots alpha square r over p and beta square r over p. First you get addition, then alpha square plus beta square 2r over p. Here write alpha plus beta whole thing square minus 2 alpha beta 2r over p. Alpha plus beta minus q divided by p square r divided by p. Then cancel q squared over p squared. Then similarly you get product alpha square plus r over p, beta square plus r over p. Then expand alpha square times beta square, r over p, alpha square plus beta square plus r over p squared. Then here r over p square, r over p, here alpha plus beta whole thing square minus 2 alpha beta r over p squared. Then simplify. Here take these two together. 2 r over p square r over p. Here minus q over p 2 r over p. Then here r over p square cancel. Then minus plus r q squared p cube. R q squared p cube. Okay. Then you can write corresponding equation. Write corresponding equation. X square minus ax plus b equals 0. Then x square minus q squared over p square x r q square over p cube 0. Then multiply by p cube x square p q square x r q square 0. Here the equation. Here the equation. Complete with me. Okay. Then part B. Part B, that is very rare question. Here x given real, then x square minus 6x plus 5 over x square plus 2x plus 2. We need to find least value. So that means we need to find range first. So here this case, multiply tx square 2tx 2t x square minus 6x plus 5. First you take this one as t. Then generate quadratic equation t minus 1 x square 2 t plus 3 x 2t minus 5 0. Now here rational function has converted into quadratic equation. Now here x real means roots real. Here roots real, that means delta greater than or equals 0. Then delta 2 t plus 3 square minus 4 a c. Now solve this inequality, cancel 2. Here 4 cancel. T square plus 60 plus 9. Here 2t square minus 5t 2t minus 70 plus 5 greater than or equals 0. Then simplify minus t square 7 6 13t 9 5 4. Now we have quadratic inequality. So if you get range here, so possible values of t, no? This range possible values of t. That means the possible value of this expression represent possible value of here this expression. Now here t square minus 13t minus 4 less than or equal 0. Now we don't have factor properly, then get complete square. T minus 13 over 2 squared 4 minus 13 over 4 square less than or equal 0. T minus 13 over 2 square. Here 16, 48, 169, 169, 16, 32, 16 times 4, 16, 104, 64. Here 3, 12, 3, 233 over 4 square less than or equals 0. To check run Hardik. Minus t square 13t 4 multiply by minus 1 t square minus 13t minus 4k. Then t square minus 13 over 2 minus 4 minus 13 over 4. Then here 16 times 4, 64. Okay. Then t minus 13 over 2 square minus 233 over 4 root square less than or equal 0. Then t minus 13 over 2 plus 233. Then t minus 13 minus 233 over 2 less than or equal 0. Then here corresponding range 13 minus 233 root over 2, 13 plus 233 root divided by 2. Then here the range. Then the minimum value. Then minimum value of t is this 13 minus 233 root divided by 2. That is the minimum value of t. T means the expression. Minimum value. මේක රයාක් එක්ෂන් එක ඒකෙත් සිම්ප්ලිෆිකේෂන් එක චුට්ට හાર્ඩ් කරලා තියෙනවා. පාඩ මේ බේසික් එක මේ මෙතනින් යනවා කියන පාත් එක පේන්න ඕනේ. ඔක ට්‍රිගනොමෙට්‍රි වලටත් එන්න පුළුවන් තැනක් මේක. ට්‍රිගනොමෙට්‍රි වලටත් එන්න පුළුවන්. Complete. Okay. Then part C. Question number 11, part C. Common root condition. Here part C. 3x square plus px plus 1 0. 2x square plus qx plus 1 equals 0. That's a common root given. So it is given there's a common root. Here let alpha is the common root. Alpha is the common root. If we have common root, the procedure, you substitute alpha to the equation 3 alpha square p alpha plus 1 0, 2 alpha square q alpha plus 1 equals 0 because the equations are satisfied by alpha. Here common root no. Therefore, equations are satisfied by alpha. Now solve simultaneous equations. Solve them. Find alpha square. Here p minus q over 3q minus 2p. Find alpha 3 minus 2 over 3q minus 2p. Here alpha and alpha squared. Then here we have minus 1 over 3q minus 2p. Then get relation. Then p minus q 3q minus 2p equal minus 1 over 3q minus 2p square. Here alpha square. No? Then simplify. P minus q. Here cancel one factor. Then 3q minus 2p equal 1. 3pq minus 2p square. 3q squared plus 2pq equal 1. Therefore say 5pq 2p square minus 3q square equal 1. That is the one. So anyway, if you have common root, the usual procedure, take that common root alpha, substitute to corresponding equation, solve them, then we can get condition and common root as well. When you solve, you can get common root, and by these two relation, you can get condition to have common root. That is question number 11, part C. Complete up that. Okay, then question number 12. Question number 12. Check this. 12 part A, mathematical induction question. Usually mathematical induction question come with question number 1. Here question number 12. Usually question number 12 will be permutation and combination question, and part B will be series question. Now here 12 part A. Here take fn function 3 times 5 to the power 2n plus 1, 2 to the power 3n plus 1. Need to show that it is divisible by 17. 17. Then let n equal 1, then f1 3 times 5 to the power 3, 2 to the power 4. Simplify. Here 1, 2, 5, 3, 16. 375 plus 16. 393. 393, 17 times 23. Therefore, divisible by 17. Therefore, true for n equal 1. That is true for n equal 1. Then let assume that the relation is true for n equal p. P integer, here define p, yeah? 1 to n value. Therefore, fp you write 3 times 5 to the power 2p plus 1, 2 to the power 3p plus 1 equals 17k. It is divisible by 17. 17k, define k integer. Then you need to get fp plus 1. fp plus 1, 3 times 5 to the power 2, p plus 1 plus 1, 2, 3p plus 1 plus 1. Replace p by p plus 1. Then 3 times 5 to the power 2p plus 1, we have extra p square term, multiply by 5 square. 2 to the power 3p plus 1 with extra p, multiply 2 to the power 3. Here 25, 3 times 5 to the power 2p plus 1, 8 times 2 to the power 3p plus 1. So for this part, you take from here 17k minus 2 to the power 3p plus 1. Then put it here 17k minus 2 to the power 3p plus 1, 8 times 2 to the power 3p plus 1. Then 25 times 17k, here 25 minus 8, 17. 2 to the power 3p plus 1. Now we can get 17 outside. 25k minus 2 to the power 3p plus 1. Definitely this will be integer. 17k dash, define k dash integer. Here 25 k integer. Then 2 to the power any positive term will be integer. No? Then integer 17k dash integer. Therefore divisible by 17. Therefore true for n equal p plus 1. Therefore, by the principle of mathematical induction, the relation is true for all positive integer of n. All positive integer of n. That is question number 12 part A. 12 part A. Complete. Definitely a yellow paper contain mathematical induction, quadratic, and trigonometry. Our main it has limits, tangents and normals. එහෙනම් ඒවා හරියටම ફોકස් කරන්න. ඒකට අමතරව මේ part අනිවාර්යව බලන්න. මේක ඇතුලේ තියෙන special parts. Then 12 part B. 12 part B series question. 12 part B. Here minus 2 r plus 1 over r square r plus 1 square. So because of these two denominator factors, we can identify this r square, r plus 1 square minus r square 1 1. Here this will be definitely the relation. So when you get common denominator, we get denominator, then r square minus r plus 1 square, that is here. Therefore you say fr 1 over r squared, fr plus 1 1 over r plus 1 squared. Likewise, you can directly write. No need to simplify. Yeah. So according to the pattern, just write. Then, hence find the sum of the terms of the series. So here the series 3 over 1 square, 2 square, 5 over 2 square, 3 square, 7 over 3 square, 4 square. It goes like that. Then you write general term. Here 3, 5, 7, 2r plus 1, r square, r plus 1 square. Then by this you write here 2r plus 1 with minus, no? Then interchange terms 1 over r square, 1 over r plus 1 square. Then say here ur equal fr minus fr plus 1. Here the pattern now. Ur pattern. Now substitute r equal 1, u1, f1 minus f2. Substitute r equal to u2, f2 minus f3. Substitute r equal 3, u3, f3 minus f4. Then r equal n, un, fn minus fn plus 1. You add it. Then you write r equal n minus 1 as L, un minus 1, fn minus 1 minus fn. So you need to put at least 3 dots here. Then add them. We can cancel this pattern. No? You can cancel them. Therefore, finally, sigma ur, sigma r equal 1 to n ur, we got f1 minus fn plus 1. Then we know fr is this. Then f1 mean 1 over 1 squared, fn plus 1 mean n plus 1 squared. Then 1 minus 1 over n plus 1 squared. Here sum of the series. Then is this series convergent? Yes. The series is convergent. Justify your answer. First you need to say the statement, okay? Here we have denominator. No? Then definitely when n goes to infinite, this will be, that goes to 0. Therefore, will be finite value. Then you say, yes, that is, the series is convergent. Then justification, limit r equal 1 to infinity ur, you put limit n goes to infinity 1 minus 1 over n plus 1 squared. Then we know this goes to 0, the solution 1, finite value. Therefore, convergent series. Convergent series. That is question number 12, part B. Question number 12, part B. Complete. Okay. Then question number 13. Question number 13, differentiation question. Usually, question number 13 will be complex numbers and matrices question. But here it is given differentiation. And also differentiation will be question number 14. Usually differentiation, application and graph will be there. But here it contains application, differential equation and limit question. Okay, anyway, let's do this. Question number 13 part A. 13 part A. Here a cone, semi-vertical angle, need to find, let's say alpha, slant height L. Then radius R, you say L sine alpha, height capital H, you say L cos alpha. Then we need to maximize the volume. We need to maximize the volume. No? Then volume 1/3 pi R squared H. Then 1/3 pi R mean R sine alpha square H. L cos, here L no, not R, L cos alpha. Then 1/3 pi L cube sine square alpha cos alpha. Now we have constant here and variables here. Then you differentiate, divide by alpha. 1/3 pi L cube, here product no, then write derivative. 2 sine alpha, sine derivative cos alpha, cos alpha again. Sine square alpha, cos alpha derivative minus sine alpha. Don't expand, factorize this. 1/3 pi L cube, sine alpha common take outside. Then 2 cos square alpha minus sine square alpha. Here write 1 minus sine square alpha. Then 1/3 pi L cube sine alpha, 2 minus 3 sine square alpha. Okay. Then you factorize this. dv divided by d alpha minus 1/3 pi L cube sine alpha. Here 3 sine square alpha minus 2. Then here 1/3 pi L cube sine alpha. Here root 3 sine alpha minus root 2. Root 3 sine alpha plus root 2. Okay. Then we have factors, no? We have factors. Therefore, then get dv over d alpha equals 0. Here to find critical value. To have critical values, we solve this. Pi L cube sine alpha root 3 sine alpha minus root 2 root 3 sine alpha plus root 2 0. Therefore, sine alpha 0, sine alpha root 2/3 sine alpha minus 2/3. Here this is contradiction, alpha, practical case, no? Then with alpha 0, we can't make a cone. Here negative angles, we can't make a cone. Then only for this possible. But here we need to get tan, no? Then root 2, root 3, here 1. Therefore tan alpha root 2. Alpha tan inverse root 2. Then you check dv over d alpha sine. Here sine alpha 2/3 root 2/3 root sine alpha not more than 1. Here sine alpha not less than 0. Therefore, with these factors, here surely positive. So less than this part negative, with outside minus, that will be positive. This will be minus, no? Sine alpha less than 2/3. Here this will be negative. Negative times negative. Negative times negative, positive. Others two positive. Yeah. Therefore positive here. Then for this range negative. Therefore we get maximum value when alpha equal tan inverse root 2. Alpha equal tan inverse root 2. Okay, complete. Okay, then question number 13 part B. Question number 13 part B. Here y equal ax plus b e to the power minus 3x. We need to get differential equation, but that not contain e terms, that not contain ab terms. Therefore, we have second derivatives, no? So anyway, you need to differentiate twice and you need to remove a and b and e, no? So if you differentiate this way, it is too difficult to remove a and b. Then you better to write this one first, ax plus b e to the power minus 3x cross multiply y e to the power minus 3x, ax plus b plus 3x, ax plus b. So now when you differentiate twice, definitely you can remove constant. So first derivative we can remove b, second derivative then you can remove a. Then differentiate, then dy over dx e to the power 3x plus y times e to the power 3x times 3a. Then again differentiate d square y dx square e to the power 3x dy over dx e to the power 3x times 3 dy over dx. Here we have 3 constant, take outside, dy over dx e to the power 3x y e to the power 3x times 3. Here 0. Now simplify. Then e to the power 3x you can cancel common. Then d squared by dx square. Here 3, 6 dy over dx. 3 into 3, 9. Y equals 0. So here the best way. First you put ex the other side, then you differentiate twice, then you can remove completely ab. There can be any other methods. Complete. Okay, then part C question. Part C. Just a limit. So here given limit x goes to pi over 4 root 2 cos x plus sin x to the power 5 1 minus sin 2x. You write this way. Limit x goes to pi over 4. Here root 2 to the power 5 cos x plus sin x to the power 5 1 over 1 plus sin 2x. 1 over 1 plus sin 2x. Here you write root 2 minus cos x plus sin x and put it here again, root 2 minus cos x plus sin x. Okay, then you can apply theorem for this. You take cos x, take here L1, limit x goes to pi over 4 root 2 to the power 5 cos x plus sin x to the power 5 root 2 cos x plus sin x into limit x goes 0 pi over 4 root 2 minus cos x plus sin x 1 minus sin 2x 1 minus sin 2x. Then here take this one as L1, here take these two as L2, L1 and L2 limits. Then L1 limit x goes to pi over 4 root 2 to the power 5 minus sin x plus cos x Okay, now you can put theorem here. Here n a n minus 1, 5a, 5 minus 1, then 5 times root 2 to the power 2, 4, 20. For that part you can put 20. Here 20. Then L2, again separating. L2 another limit. Check it now. L2. Limit x goes to pi over 4 root 2 sin x plus cos x 1 minus sin 2x. Here you write limit x goes to pi over 4. Here root 2 1 over root 2 sin x 1 over root 2 cos x. Here sin pi over 2 sin 2x. Here for this part write sin x plus pi over 4. Sin x plus pi over 4. Okay. Then take root 2 outside. Limit x goes to pi over 4. 1 minus Sin x plus pi over 4. Sin pi over 2 minus sin 2x. Again you put here sin pi over 2. Then you CD and CD here. Limit x goes to pi over 4. 2 plus c plus d over 2. C plus d over 2. Then pi over 2 plus x plus pi over 4 over 2. Sin c minus d over 2. Then pi over 2 minus x minus pi over 4 over 2. Then sin minus sin 2 plus c plus d over 2. Sin c minus d over 2. Okay, these are CD equations. Now we simplify. Simplify. So we have to go further. Then root 2. Limit x goes to pi over 4. Here cos. Here 3 pi over 4 over 2. 3 pi over 8. Method pi over 4 then we got 2 pi over 4. Pi over 4, 3 pi over 4 over 2. Pi over 8 plus x over 2. Here sine pi over 2 minus pi over 4. Then pi over 4 over 2. Pi over 8 minus x over 2. Here cos pi over 4 plus x. Here sine pi over 4 minus x. Then further you write half angle here. 2 sine pi over 8 minus x over 2 cos pi over 8 minus x over 2. Now cancel this factor. Now here we have 2 cos 3 pi over 8 plus x over 2. Here 2 cos pi over 4 plus x cos pi over 8 minus x over 2. Now we are where we are cos 3 pi over 8 pi over 2 pi over 2 plus pi over 4 pi over 8 pi over 2 minus pi over 8 4 pi minus pi 3 pi over 8 then root 2 over 2 limit x goes to pi over 4 may I get the x over 2 get the 3 pi over 8 pi over 2 minus pi over 8 minus x over 2 now it is there. Then cos 90 minus b sine pi over 8 minus x over 2 cos pi over 4 plus 6 cos pi over 8 minus x over 2. බලන්න ඔතෙන් නරක කරන්න එක තැනක වැරදිලා තියෙනවා සිම්ප්ලිෆයි කරලා දෙක තැනක් වැරදිලා තියෙනවා කොයිෆිෂන්ට් සිම්ප්ලිෆයි ඔතෙන් නරක කරගෙන යමු කොයිෆිෂන්ට් එක ඉස්සෙල්ලා මම මේක මේ මෙතනින්ම ෂේප් කරගන්නම් අර මේ වරද්දක් වෙලා නැහැ මගේ. මේක තව යන්න පාත් තියෙයි. මම මෙතන මෙහෙම කරගන්න. මෙතන 5 over 4 plus 6 5 over 2 minus 5 over 4 plus x minus x sin करगन 5 over 4 plus x cos change to sin then 5 over 4 minus x here sin 5 over 4 minus 6 then method लगाना limit x goes to 5 over 4 then method sin 5 over 8 minus x over 2 method sin x here 2 sin 5 over 8 minus x over 2 plus 5 over 8 minus x over 2 make a half triangle again cos 5 over 8 minus x over 2 make a square 2 root 2 1 over cos 0 1 over 2 root 2 है 1 over 2 root 2 है then मेथड में आप half triangle करेगा एक सिंपल का तर आगे 1 over 2 root and I can then substitute करा 1 over 2 root 2 5 over answer 5 over 2 make a तव टिकක් सिंपल වෙනවා මෙතන conjugate කරා මෙතන conjugate කරා ඒකයි මෙතන මේ linear function එක තියෙනවා ඒ linear function එක √2 sin x plus 5 over 4 ඒක කරගන්න අපිට පොඩ්ඩක් simple ලා complete Okay, see question number 14. Integration question. Usually integration question comes in question number 15. Now here, question number 14, part A. X to the power 2/3 1 plus x dx. Okay, now here 1/3 power we have down here, and x to the power 1/3 you take t, then x equal t cube, and differentiate 3t square dt. Then x equal, put it here, then x 1/3 t, then here t square. Dx means 3t square or 1 plus t cube dt. Take 3 outside, t to the power 4, t cube plus 1 dt. So now it has converted into rational type. Then t to the power 4 you divide by t cube plus 1. Then here t to the power 4 plus t, subtract minus t. Then 3 integral t minus t over t cube plus 1 dt. Then 3t dt minus 3 t cube plus 1 dt. You know how to integrate this. T squared over 2 plus c1 minus, you say here I. Say here I. 3i plus 3i. Then separate I and integrate it now. Then t over t cube plus 1 dt, rational type. Here get partial fractions, t plus 1, t square minus t plus 1 dt. Then a over t plus 1 dt plus c over t square minus t plus 1 dt. Now t identical with a times t square minus t plus 1 t plus 1 bt plus c. Now let t equal minus 1. Here 0. Here 3a. A equal minus 1/3. A equal minus 1/3. Then t square coefficient 0, a plus b. B equal 1/3 constant. Here 0, a plus c. A plus c. Then c 1/3. Now here 3i. Take full with 3i. Then you can cancel 3. Then a means 1/3 t plus 1. B means 1/3 t square minus t plus 1 dt. Then cancel 3. Then minus dt over t plus 1 t plus 1 t square minus t plus 1 dt. Then minus a plus 1 ln t plus 1 not plus c2. And to integrate this one, put half 2t plus 2 t square minus t plus 1 dt. Then the denominator derivative 2t minus 1. Then put minus 1 here plus 3. Then we can integrate this part. Here minus ln t plus 1 what plus c2 1 over 2t minus 1 t square minus t plus 1 dt plus 3 over 2 t square minus t plus 1. Then here complete square t minus 1 over 2 square 3 4. මේ පේන්න පොඩි එකට ගාන ඇතුලේ දුරයි. Then minus ln t plus 1 what? C2 half ln t square minus t plus 1 what? C2 plus 3 over 2. Here put tan inverse 1 over 2 3 over 2 tan inverse t minus half over 2 3 over plus c. Here C3 C4. Here this is equal to I. Then finally you can get this integral. You can get this integral. Then final integral you say the I dash. Therefore I dash 3 over 2 t square minus ln t plus 1 what? 1 over 2 ln t square minus t plus 1 what? Root 3 tan inverse 2t minus 1 over root 3 plus c. මෙන්න තමයි ෆයිනල් ආන්සර් එක. හරිද? දාන පොඩියට වගේ තිබුණාට ඒක ටිකක් දිගට යනවා. ඔය සබ්ස්ටිටියුෂන් එක කොහොමද යන්නත් වෙන්නේ. කම්ප්ලීට්. මෙතන correction එක කරගන්න x එක remove කරගන්න. Okay, then tan inverse xt 1 over 1 plus x square dx dt as x cos 0 tan inverse 0 0 x cos 1 tan inverse 1 pi over 4. Then here 0 to pi over 4 tan inverse xt here dt then t square over 2 0 to pi over 4 then 1 over 2 pi over 4 square minus 1 minus 0 pi square over 32 pi square over 32. Okay, then 14 part C. 14 part C. That's modulus function. Then to integrate modulus function, you need to write definition first. You need to write definition first. Here need to integrate 0 to 2 pi. That means full rotation. If you consider full rotation, then 0 to pi over 2, 0 to pi over 2 positive, pi over 2 to 3 pi over 2 negative, 3, sorry, 0 to pi over 2 positive, pi over 2 to pi negative, pi to 3 pi over 2 negative, then 3 pi over 2 pi again positive. Then you have three different sections. So 0 to pi over 2, then pi over 2 to 3 pi over 2, then 3 pi over 2 to 2 pi. But that is okay. Yeah? But here we have a special thing. Check this. Now here 0 to 2 pi cosine modulus p is coming. Then let's see what is the definition of this. Here x axis, y axis, cos function graph. Here 2 pi. Here this is pi over 2. Here pi. So here this idea. Here full bounded area. Bounded area. Therefore, instead of this, you write 4 times 0 to pi over 2 cos x dx. Here 0 to pi over 2 integrate, then 1, 2, 3, 4 sections. Then 0 to 2 pi integral, you write instead of that one, you write 4 times 0 to pi over 2 cos x. Now need to put modulus because this part positive. Now for cos integral, sine derivative will be minus cos integral minus sine. 0 to pi over 2. Then minus for sine, plus sine pi over 2 minus sine secant. Then we get 4. Answer 4. That's question number 14. Question number 14. Complete. Okay, then last question. I do question number 17. Okay, question number 17. Check it now. Here 17 part A. 17 part A. Part A. Here sec theta cos theta plus sin theta. We need to derive first relation and spar. Then you spar both sides. Sec cos theta cos theta plus sin theta spar. Expand cos spar plus sin spar. 2 sin theta cos theta. Here 1 sine 2 theta. Put 1 the other side. Sec bar theta minus 1 equal sine 2 theta. Then here tan square theta equals sine 2 theta. Here part A first part. Then second part. I take right hand side. Tan square pi over 4 minus theta. Here tan pi over 4 minus tan theta. 1 plus tan pi over 4 tan theta to the power 2. Tan pi over 4 1. 1 minus tan theta. 1 plus tan theta to the power 2. Now write in terms of sine cos. Sine theta over cos theta. Sine theta over cos theta. Then here cos theta minus sine theta. Cos theta plus sine theta square. Then expand it. So when you expand, we get cos square plus sine square minus 2 sine theta cos theta upstairs and downstairs. Cos square plus sine square 2 sine theta cos theta. Then here 1 minus sine 2 theta 1 plus sine 2 theta. Here sine 2 theta sine 2 theta. Then we know sine 2 theta tan square. So initial proof sine 2 theta tan square theta. Then 1 plus tan square theta. Then we know this one cos 2 theta equal left hand side. Equal left hand side. Okay. There is no general identity. There is no general identity, but you need to get it done. Then part B, special angle theta equal 36 degrees. Then phi theta equal 180. 3 theta 180 minus 2 theta. Then sine 3 theta. Sine 180 minus 2 theta. Then sine 180 minus 2 theta. Sine 2 theta. Sine 3 theta equals sine 2 theta. Okay, sine 80, 36, 54, 72, all are special angles. So now first relation is okay. Now sine 3 theta. 3 sine theta minus 4 sine cube theta. 2 sine theta cos theta. We know sine theta equals sine 36 now. Then that not equals 0, then you can cancel one factor. Then 3 minus 4 sine square theta 2 cos theta. Then here 1 minus cos square theta. Then write 4 cos square theta minus 2 cos theta minus 1 0. Then here we have quadratic equation. Theta means 36 now. Then write solution. Then cos theta equal minus b plus or minus b square minus 4ac root divided by 2a. Now simplify 4 to cancel 1 plus or minus root 5 divided by 4, but cos theta equal cos 36 greater than 0. Therefore, you get cos 36 1 plus root 5 divided by 4, not 1 minus root 5 divided by 4. So if you select 1 minus root 5, that is negative, then you get only positive. That is cos 36. Complete. තා පාර්ට්ස් දෙකක් තියෙනවා එකක් ඩිස්කස් කරන්න. Okay. Now see question number 17 part C. Sin square pi over 8 cos square 3 pi over 8. Sin square pi over 8 cos square 3 pi over 8. Find the value without using trig table. Sin square pi over 8 cos square 3 pi over 8. Finding double angle relation. Sin square theta 1 minus cos 2 theta. Then pi over 4 divided by 2. Here 1 minus 1 plus cos 3 pi over 4 divided by 2. Sin square theta equal 1 minus cos 2 theta over 2. Cos square theta equal 1 plus cos 2 theta over 2. Now simplify. Here half minus half cancel. Minus cos pi over 4 minus cos 3 pi over 4. Then here minus and here minus. Don't get minus outside. Then half times 6. Then cos pi over 4 1 over 2. 3 pi over 4 pi minus pi over 4. Pi minus pi over 4. Then cos pi minus theta minus cos theta minus cos pi over 4. Here then 0 here. 0. 0. Okay, then part D. Sin A plus sin B. Sin A plus sin B. Cos A plus cos B. Use CD. 2 sin A plus B over 2. Cos A minus B over 2. 2 cos A plus B over 2. Cos A minus B over 2. Cancel. Then tan A plus B over 2 equal right hand side. Then ABC triangle. Then A plus B plus C pi. A plus B pi minus C. A plus B over 2 pi over 2 C over 2. Therefore, sin A plus sin B cos A plus cos B equal tan A plus B over 2. Then write here tan pi over 2 minus C over 2, that is cot C over 2. Cot C over 2. Okay. ඒකේ තව ෆැක්ෂන්ස් දෙකක් තියෙනවා අපි ඒ දෙක වෙනම පස්සේ ඩිස්කස් කරමු. දැන් ටේප් එක ඔතනින් අතර කරමු.